In this video, we're going to discuss 4 properties of inequalities for real numbers, and we're going to discuss the triangle exterior angle inequality theorem. And so let's start with the properties of inequalities. There are 4 of them, and we'll just briefly discuss each of them. They're pretty easy and kind of obvious things. The first one says that if you've got 2 values, which we'll just call A and B, that one of 3 things always has to be true. Either A is less than B, A is equal to B, or A is greater than B. There's no other possibility. It's got to be exactly one of these 3 things, and that's just a mathematical property that states that fact. And so, if you've got 2 people, either one of them's older than the second one, or the first one's I'm sorry, I said it backwards from the way of looking at it. If the first one's younger than the second one, or the first one's older than the second one, or they're exactly the same age, is another way of looking at that. Then we have something called the transitive property of equality that is useful when we're comparing 3 things together. It says if we've got a value and that's greater than a second value, and then that second value is greater than some third value, then what must be true about the first one and the third one? Well, if A is greater than B and then B is greater than C, then A must be greater than C. And we can state it in reverse. We can say if A is less than B, the first value is less than the second one, and then the second one is less than some third one, then the first one must be less than the third one. That's the transitive property. We've used the transitive property of equality before, and the transitive property also applies to inequalities. And then finally, we have already discussed a lot in algebra of the addition and subtraction property of equalities. We know that if we have two sides of an equation that are equal to each other, we can add the same thing to both sides and then the results are still equal, or we can subtract the same thing from both sides and the results are still equal. So we use that all the time to solve equations. We also use exactly the same facts to solve inequalities. If some value A is greater than some value B, then if I if I add the same amount to both A and B, the left-hand side will still result in a greater value than the right-hand side. So A plus some value is greater than B plus that same value. And this should say if A is less than B, this should have been, no, that's right, the subtraction property, I'm sorry. If A is greater than B, then we can subtract the same thing from both sides. That's the subtraction property of inequality. If you have 2 things, the first one's greater than the second one, then subtracting the same thing from both sides results in the same comparison. So we've used those properties before to solve inequalities. All right, now we have this thing called the exterior angle inequality theorem. You may remember that we had in a previous chapter an exterior angle theorem, and the exterior angle theorem discussed what was true about an angle that was defined to be an exterior angle. Here in this diagram, we have an exterior angle of this triangle. We form an exterior angle when we take a side and we extend it straight out, and then the angle is formed between this side and that extension of side AB. So this angle here is an exterior angle of the triangle. And we learned, of course, we already knew that since this forms a linear pair that these 2 angles are supplementary to each other. But then we also learned that this exterior angle was equal to the sum of the remote interior angles. And the remote interior angles were the 2 angles inside the triangle that were not adjacent to the exterior angle. So angle C and angle A here are the remote interior angles to this exterior angle CBD. And we learned that the measure of the exterior angle is equal to the sum of the remote interiors. So 67.57 plus 33.51 is equal to 101.08. The sum of these remote interiors is equal to the exterior. And that's always true. No matter how I readjust the triangle, these 2 angles always will add together to be this one. And that's kind of based on the fact that these 2 angles add up to 180, and then also inside the triangle, these 3 angles add up to 180. So if this angle CBA plus angle C plus angle A is 180, and angle CBA plus angle CBD is also equal to 180, then angle CBD must be the same value as angle C plus angle A. Well, in this chapter, we're going to be just discussing some inequalities in triangles. And so it'd be pretty easy to say, well, if this angle CBD is equal to the sum of angle C plus angle A, then angle CBD must be greater than either angle C or angle A all by itself. And so we're simply just saying that this exterior angle is greater in measure than either one of the remote interior angles alone. Since it's equal to the sum of the two together, it must be less than either one by themselves. And so the exterior angle of a triangle is always less than either of the remote interior angles. Now, in this case, it's also less than all three angles. That's not true if that's an obtuse angle. Now, this angle inside the triangle is greater than the exterior angle, but that exterior angle is still greater than either one of the two remote interiors. Angle CBD is still greater than angle C, and it's also greater than angle A, as it's equal to the sum of angle A and C. And so that's what the exterior angle inequality theorem says. It says that the measure of an exterior angle of a triangle is greater than the measure of either of its corresponding remote interior angles. In this diagram, that means that the measure of angle 1 is greater than measure of angle A, and also that the measure of angle 1 is greater than the measure of angle B. And of course, don't forget that the measure of angle 1 is equal to the measure of angle A plus the measure of angle B.